Hi everyone. I'm experimenting with stable diffusion integration to Grasshopper parametric workflows, and for this video, I will extend the text to image tool to generate topographic landscapes. So the tool that we're building is actually working on a remote server that we access, and I'll show you here. Our students are actually using these as well. So this is kind of the server activity right now, and we can actually send prompts and use other types of inputs as well. So this is the one I sent, and it retrieves an image, and I'm able to preview the image using native Grasshopper tools. So if you go to here, there's an image resource. This basically visualizes the output image. And then there's another tool, import image, that visualizes it as a mesh in Rhino. So what I wanted to do was to show you how you can actually work with this type of workflow with stable diffusion and generate a 2D map. So right now I only wrote two keywords, map and topography, but what I want to do is develop this a bit further. Like we can add a few more keywords. Let's call it landscape and valley, river, and I'm not going to add any negative prompts yet, but once we generate an image, I'm only using inference as 30. And let's actually look at it from this view. There we go. So right now we're getting a perspectival depiction of a landscape. So maybe we can actually take that out of the generation. So I'll include it in the negative prompt. And let's add a few more, like mountain, maybe top view from space. Keywords that will actually make it a bit look like Google Earth images. So there you go. So we're actually getting nicer results. It's kind of hard to say if this is a perspectival drawing or actually or an aerial view, but technically speaking, it's getting close to the maps that I want to generate. And you can further engineer this by including more prompts. For instance, let's say we don't want any text, border, roads in our generation, and we can also include some other keywords like depth, relief, height. But let's see if this would work. So I want it to be yeah, it's kind of a distorted perspective. I guess we need it to be a top view. Maybe we can push this a bit. I think the depth and relief, maybe we move these towards the end. And I add a top from space and Google Earth like as a keyword. Let's try that. So yeah, this is still looking at an angle. So Google Earth wouldn't give flat images, but so it's kind of yeah, this is kind of a perspective. Maybe we take out sky as well, and we have the perspective, and I'll add aerial because we don't want it to look like a picture taken from air, but we want it to be a picture from space. So this is kind of getting closer to it, and once we actually like the results, this is what you can do. So this tool that I showed you actually generates it as an image, and we can actually access this image data. So it's a mesh actually, and if you bake this, you would actually generate the image as a textured mesh. So using this, we can generate a topography map. I'm still getting texts, so it might have to do with having map as a stronger influence for the generation. Maybe we move it like this and take out height. So let's see. So let's generate an image that we like, and yeah, this is definitely taken from space. It has the glow, and this too. Maybe I take out from space and see. Okay, let's start working with this. I mean, something like this will do. Okay, this has the halo. Yeah, maybe a bit more denser. Maybe we write mountainscape. Oh, this is definitely a map. Maybe we also include mountainscape. And I actually take in a result that I really liked. So let me look at some of the keywords. Road stepped, planimetric. Planimetric might help. Actually, top planimetric. We have the top view as well. Valleys, river, relief, landscape, rivers. Yeah, I think this would do. And then straight line, scape, shiny blue, perspective, text, and border. So I have those two. I think this should be fine. Yeah. So I'm getting this type of legend. Let's actually include that too, because we don't want it to have any borders or map like information. Yeah, this is fine. So once you get this is what I do. I actually take in the image data. So here is the file. You can actually find this tool under, if you go to parameters, it's called import image. So I'll take the import image, and we can actually sample this at another resolution. So for the X and Y grid, we can start with a lower resolution. Let's say we want 64 by 64. And I extract the mesh vertices, then look at the colors and calculate black and white image. So I'm trying to extract, do a fast calculation for depth analysis, so that this could be translated to a height map, basically. Now it's not working perfect, but let's actually look here. You can see it's kind of noisy because the depth analysis requires another type of mask image. So this is something that we can directly do from the generated image, but you would basically need another depth analysis algorithm running on this. So once I get the mesh, I then blur it, do some smoothing as well, and I arrive at the mesh construction like this. And you can actually add more depth to this. So if I increase the height, you can see it gives it kind of a topographic landscape, and we can bump up the resolution a bit more. So it takes a bit more time to calculate, because if you increase the vertex count, then technically it's extracting a lot more information from the image. So let's see if we can downsample it to, yeah, this is 256 by 256. So now we can actually bake this as a textured mesh, and this will be an image inside. It will be basically a procedural landscape inside Rhino. Now we have some groovy depiction, and that's because the noise from the image that we get. So technically speaking, this is not a perfect interpolated data for the depth analysis. So this is kind of giving us a procedural map. But let's actually try generating another one, and I'm going to just bump down the resolution again and see how fast this would work. So I'm going to generate a new image. It takes like a few seconds to generate the map and then sample it as a mesh, but I'm only using 64 by 64. So if I increase one more resolution, to 128. That's kind of the topography that I get. So I'm going to bake this as well. Let's actually generate quite a few, and I'm going to move this mesh with the texture to the beginning of my script. So what I would do is generate a map and then bake it and see how long it will take. So I think it's not showing me the parts that are staying low, but this seems like a perspective. It can still generate perspectival images like this, so you can see it has sky and other properties. Maybe moving this to an earlier phase like here for the negative prompt might actually help us fine-tune the prompt a bit more. So let's generate again. So there we go. So we can generate a lot of different colored landscapes. This one is actually not that bad. Let's actually bake this too. So I'm going to generate quite a few, and we basically now have an AI engine that can output procedural landscapes. So I was able to develop this using the text-to-image stable diffusion tool that generates an image. So we engineered this image first and then use the information of the image to map it onto a mesh with some depth. So I hope you enjoyed this tutorial. We will do other exercises with stable diffusion. So please stay tuned, and if you subscribe to the channel, you can follow content like this. And thanks for watching.